Hi, Jessica, how are you?
Good.
Okay, we'll get started. Today, we are moving on to the Unit 3 data structure. So data structure in C language primarily is structure and array. And another one called pointer. These are three things that you need to know in C language. And when we move on to C++ language, all these still the same, okay, still the same. So here actually, in C language, you're not only learning for C, but also learning for C++ language, okay? So that's very important. Let's actually, now, before we get started, because both of you are going to college, let's look at UC Irvine Computer Science 4-year study plan, okay? Because both of you will go to college soon, and then let's look at this sample study plan. For Jessica, you're directly going to this program, so this is very important. So basically, you have Python 1, 2, 3, 1 semester, 1 year, okay, 1 year. And then you have CS, where it is 45C, this is C++, 2 and 3, 2, okay. And then 46, this one is C++3, data structure and algorithm, okay. So basically 1 year Python, about 1 year of the C++. And this CSPT1 is a C language and assembly. Okay, so this is roughly the language education in Irvine studies, okay? And for ASU, okay, for ASU you cover it already. You have the 110 that actually is Java, okay? And then 205, maybe 205, I forget it, is a data structure and algorithm. So this one directly jump into here, okay? And 110 is like initial language. But anyway, these are for Irvine. So let's look at something else. Let's look at Stanford. Stanford do provide you a lot of different languages. They do provide you 106A, 106AP, 106J, 106B, okay, 106. These are different 106 courses are Java, JavaScript, Python, C++. These different languages are level 1. Okay, basically they teach you different kind of level 1. And then there is a level 2 course right here. It's actually object-oriented programming. And then they have level 3 data structure and algorithm in 166 and 161. Okay, so basically they have quite many courses, but usually they don't teach you so many. Usually a lot of students just take one of these, that is, okay, because you don't have that much time in college to learn everything. So for us, we use APCSA to learn these, APCSP to learn this, right? And then the third year, we teach you the C++ 1, 2, 3 is actually covering this, okay? So that's why you want to learn C++ from us. For Berkeley, they don't teach you this, okay? All these, they are not teaching you this. This is they suppose you already know this. So beginners Java, beginners Python, beginners C language, beginners C++, they all assume you already know it. So they directly jump into the data structure and algorithm. So this is already level 3, level 4 courses. And this is C, this is Java, this is Python. Okay, so different school have different approach. Okay, and Berkeley, assuming you are jumping into the level 2 or level 3. Okay, anyway, here we are trying to prepare you to the third year of the C++. We have the APCSA to cover this, CSP to cover this, and then we are on C language, and then C double plus 1, 2, 3 to cover this. Okay, that's our approach. So let's continue. Okay, that's the where we are, and then after that we still need to learn a lot of things in college. In college 4 year, you need to learn a lot of things in college, including the C double plus acceleration, programming CUDA, and then natural language processing, large language model, machine learning, and data science. And then now in the job market, there are still a lot of AI-related jobs that you can search for. Okay, that's the ultimate goal, that you go to college and learn computer science, that's where you are going. Okay. Anyway, let's go back to our chapter 7, pre-processing. And this is the first chapter in the UNAM 3 data structure. We briefly talk about array and the structure before, and we also talk about the pre-processing before. But right here, we are going to systematically teach you what's the data structure here. Okay. What is the data structure? So let me repeat it again. C language, you have a pointer, array, and the structure. Array and structure are two only data structure that C language provide. Okay, they don't provide class. Okay, C language no class. C language using only these three. Okay, C double plus provide these everything. Okay, Java provide you class, array, but no structure, no pointer. This is Java. Okay, this is Java. So today we are going to starting from Java's concept of these, and then we're also talking about Python's class, and then finally we'll go to this C language part. Okay, let's get started to review this again in Java. So let's get started with the Java class. Okay, let's actually create a program. Let's call it Java. Okay. Okay, let me change it. Okay, I actually forget. Let's use a capital P. Okay, because Java's class is usually capital. Okay, so here you can write public class. Okay, point. So Java's structure usually is just class. They don't have structure, so they directly give you the class. Okay, now you will have the double X and double Y. Okay, and then you have a constructor of the integer X, integer Y. Okay, and then you do this that X equals X, this that Y equals Y. So there give you this, and this actually is current object. And current object is a current, this variable is a reference. Okay, it's a reference. Okay, I think both of you know it. Now you will have a public, okay, string function, okay. And then this one will return. Okay, let's assume that we actually get this. And then let's put a getter and setter as well. Okay, so let's put the public tuple get X. I use Java because most of you know this better. Okay, so let's actually use this. Okay, this norm usually is the distance from your point to the original point. Okay, so that's actually use mass that square root of x times x plus y times y. This actually is the absolute value of xy. Okay, you have point xy. The original point is 0, 0. How long this one is, we call it norm. This is square root of s squared plus y squared. I say this one is okay. Okay, the distance between these two. So far, okay? Hello, so far, okay?
Yeah.
And then you actually can write another program called test point by Java, okay? And in this test point for Java, let's put in public static, okay, void name. Okay, and let's have a point P1 equals new point 3, 4, okay? And it's system that out a green line, okay, of the P1 that norm, okay? Let's just do it, okay? And let's also print out system that out that green line. Print out P1 as well, and P1 would directly run the toString function, okay? That these are what you so far you get familiar with, and we actually directly run it. This one Java FX. This is Java FX. No, we don't have a Java FX. Okay, let's use a terminal. Okay, I don't know. Let's do Java C. Okay, and then that Java. Okay, Java C. Okay, and then test point that Java, and then Java test point. Oh, public static void main. What's wrong? Oh, I'm sorry. Here I'm missing string. Right. ARGS. Sorry. That's where I miss. Okay. Then we got it. Okay. I'm sorry. I actually forget this. And then it consider it's a Java FX program. Okay. So let's do Java C test point that Java. And then run Java test point. This is the way if you use the command line to compile your Java program, okay? So far, okay?
Yeah.
How about Jessica? Are you okay so far?
Yeah.
So this one is the Java classes, okay? So let's do this, okay? Let's do this. Let's go back to the where it is. Go to this C here, go to the, this is C development, but under here, chapter 7 that I create, I have this. Let me actually create another one. Let's put as Java, okay, and move all these files under Java, okay, because we are going to create more files. So here I'm going to, okay, so everything going to Java. So now let me create another folder here. Let me create Python. So let's look at Python and then look at the similar program, okay? So under Python, let's create a new file. This one call it point.py, okay, so point.py. So here I'm going to declare a Java Python class. Let's call it point, okay? So this. And now I want to have a constructor. So the constructor should be a function. So it's defined, okay, underline init, underline this. and you will have a variable called self. So this one is very important. It's the first parameter always is self. Okay, this self is the same as this in Java. Okay, and then you will have x and y, and then self that x equals x. Oh, this self that y equals y. So this is self that x and self that y is the instance variable. So it's similar to double x and double y, and then we already show you in Java. Okay, so this is the same as you assign this that x equals x, this that y equals y. Okay, so this one you have the init function, and then you can define that x function. You also need a self, because this one, when you have a self, it will be an instant function. With self, it is a instance function. Okay, without self, it will be a static function, a class function. Okay, so class function and the so-called instance function in Java language. Okay, let's actually use another editor to open that file. So in Java, let me open it again. Let me open it with Notepad double plus. Okay, so here, if you want to have a class function, you use static, right? Static function that will be a class function. Right here, we don't in Python. In Python, we don't have a static, so you have the first variable as a self. That would be an instant function. You don't have it. That would be so. If you define another function, let's assume that here you actually just put a pass. Okay, and then you define another function called get g, and then you don't have a self. Then this one will be a class function. Okay, so that's the difference. And it is the same as a static function, okay? But we don't need this. Let me get out of this. So this one you will return self.x, okay? And then define get y, okay? And this one is the self function. Okay, I'm sorry. Here I would actually, okay, let's do self function. This one I will return self.y, okay? And you just define, okay, set x, okay. So here you will self and then x, and then you should self that x would be equal x, okay. And then that had a define, okay, set y, okay, self, and then y, okay, and then self y equals y, okay. So these are the function that defined in Java. Let's put them into one line. So we save lines, okay? Save a few lines, make the program smaller, okay? So this one is the Python format. This one, I think you know it. Let me move it to a different location. Put it on top of here. Okay? And then make this one as one line. Okay, so it's like this. So you have a constructor and these getters. And then you have the define node. So you will need to import a mesh. Okay. I'm sorry, this is self.x and self. These are the instance variable. Okay. So I'm writing this in the Python format. Okay, and then you will have to string function is defined. It's not called to string function because underline str function. Okay, and then you also need to have a cell. Okay, this cell will return what is similar to the Java program. So let me copy from Java. Return this. But Java cannot do this. You have to do str to convert the double into string. Okay. Python. Okay. So this one is your class, and then you can try class P1 equals point or 3 and 4, and then print P1. Okay, and then print P1 that none. Okay, these are what it is. And then we actually do save, and then we run. Oh, this one we forget the save that one. Okay, remember you always need the cell variable to use the instance variable. Okay, and then the Python part working fine. Any questions so far?
No.
How about Jessica? Are you okay so far?
Yeah.
I'm reviewing the class design for both Java language and Python language. Okay, I do this on purpose. Okay, because we are going to go into the C language part for the structure. Okay. Okay, so far this one is the Java's point function and the point class and Python's point class. And Java, okay, here we actually miss something. Okay, let's go back to the Java part. Java part with the get x, get y, but we do not have a set x, set y. So let me actually copy. That's okay. So here, let me add the set x. Okay, and this one should be this the x equals x. Okay. This one should be this the y equals 1. Okay, so this is setters are done. And then double 1. Okay, so this one should be set 1. Okay, and these are void function, no return. Okay, so these are setters. I forget the setters when I write the Java part. Okay, but it's okay. Let's just save it. Okay, so far I finished this one. Okay, now let's go back to our C language. Okay. So let me open folder. This is chapter 7. Here we have the Java and Python. So let's actually create another one. Let's call it C language. And open this one in C language. Now we are going to write something similar to wait and make mistake. Let me open folder again. I choose the wrong. Let's choose the C language. Okay, so I'm going to design a C language class similar to class, but we don't have class. We actually don't have class. So let's create something. Let's call it point.h and point.c. Okay, so point.x and point.c. Okay. Jessica, you missed some classes. Let me ask you, what is the .h file and what is the .c file? Do you
Is
know?
the H like where you put all the names of the classes and stuff and the structures?
Yeah. So H is to inform the compiler what do you have, right? But C is called implementation file. C is implementation file. The H we call it the header file. So header file usually is telling the compiler that what you have. So usually you may have a public function, f function, but semicolon. There's no curly brace to implement that f function. You only tell the compiler what it is. Okay. Okay, that's fine. Okay, I just want to make sure you know what is the .h and .c file, the difference. So now you actually want to define a .c file and a .h file. Okay, now let's get started with the .c part. Okay, so here we would like to have include stdio.h. This one, every time we need it because printf will need it. Okay, and then let's see, you would like to have a class. But this class usually is called structure point. Structure point define a structure, and at the end you need to have a semicolon here. Okay. So structure point is to define a structure. Structure is a record. A record have data of multiple fields. Okay, so you want to define x and y. So that's a structure. So structure point, you have double x double y equal 0.0. Okay, so this is your let's don't have it. Let's put it. So this one is a pointer. Okay. Okay, this one is a pointer, and then you want other people to do it, so let's do it in here. Okay. So right here you may want to have a, let me see, one moment. So you define a point, and then you can do type define. Okay, a structure point as point. Let me use a capital. Lowercase also work, but let's use capital. So by doing this, you're saying that this structure point type can use the capital point as an example. Is that okay? As a different name, So original the data type is structure point. Now we define it as a point type. Okay. So something like that. Okay, so let's look at the main program. So let's do main program. Okay. And then we can have a point. Okay. Point P1 equals 3.0, 4.0. Okay, so this one create a point. Okay, now we want to have different function for it. Okay, so right here, let's actually look at this one. You work on this. The constructor, you do not need constructor, you directly write the data like this. You assign the data of the 3.0 and 4.0 into 0.1. Because when they assign, the first number will be assigned here, second number will be assigned here. Okay. This is similar to array. When you have an array of integer a of 3, and you directly put in 1, 2, 3, this 3 number will be assigned to A0, A1, A2 directly. This number will be assigned to here. Okay, the same thing. They just follow the order. The first one will assign to A0, second one assigned to A1, third one assigned to A2. Okay, here it is a structure. So your first number will automatically assign to double here. Okay, so this one is similar to constructor. Any questions so far? Any questions so far?
No.
No? Let's print now right away. Okay, so now we want to print this one. So to print this one, you already have a f.1. Okay, you already have a 0.1. And then you want to print out this point one. You want to print out this data, okay? You want to print out this data. So right here, you can write a void, okay, print point, okay. So print point right here, you can put a point P, okay. And then you do print the F. Now let's use point two, okay? Okay, you can use this. You can also use this. Okay, now let me ask Benjamin, what is the difference between this one and this one?
think I remember using this on an assignment a while ago. I think star P. Hmm. I can't exactly remember. I haven't used it in a while.
So when you do this, what will happen?
It asks for a parameter P. It asks for
So when you let's see, when you write here, you do print point of your P1, what will happen?
it will print 3.0, 4.0.
I'm not asking that. When you pass the parameter P1 to P, what will happen to P?
What will happen to it gets plugged into the function, right?
What do you mean by plugin?
So the function would grab the x value, which is 3.0, and then the y value, which is 4.0. Or
So in your main function call frame, you do have a P1 object, you have the X and Y. That's a 3.0 here, 4.0 here.
yeah,
And then what will happen to this P in the print point call frame? There will be
it
P
inherit it gets the x and y values. It gets the 3.0 and 4.0.
So basically you copy this from here to here,
Yeah,
copy this to here to here.
yeah.
Okay, that's what this one will happen. Now, so what will happen to if you use this?
Oh, it inherits it instead of
What
just
do you mean by inherited?
So it like just it takes the value and it actually makes like a new p variable with those x and y values.
No, you are inventing something, so you really don't understand it. You're trying to invent something that you don't know. How about Jessica? Can you explain it? What will happen to this P?
Is it like it points to P1?
It point to P1, so this P is a pointer. So the first one, let's actually use this one. This one actually, you had a P1 right here is XY, is 3.0, 4.0 is a P1, and then you create a similar P right here. You also had a PS1, and then you copy the value copy the value of this one to here is a 3.0 copy to here, 4.0 copy to here. So this P is a local variable, getting the same value of the value from P1 from your main function. While this pointer is different, you create a new variable pointer called P. And this P, you need to use the address of this point one. So that's so this address is A2 P4. You put A2 P4 to here, and the value will point into here, pointing to this address of this object here. Is okay?
Yeah.
Okay, so these two are different. You must keep them in mind. Okay. So here, either way will work. Let's take out this one first. Compile with the first version first. So let's do queen point P1 right here. And let's run. And we got this one, okay? Now, if I want to, okay, now let me actually take out this one. And open this one. Open this one is a pointer. It's a pointer now, so you cannot use a P1. You have to put the address of P1 to there. Okay, so that's the difference. Here is a pointer, so you need to put the address of it to call this function here, this version. Okay, and that will give you the same result anyway. Is that okay?
Yeah.
So far, okay?
Yeah.
Jessica, are you okay?
Yeah.
So this is P in a way, let's call it this. Still working. So this variable is similar to this. So making this way, this print function is just like your toString function associated with your class. So this is the way that your C language write class. Your first variable is similar to Python. That's why I'm using Python before. Because the Python version, that's why I show Python, also showing Python. Because Python, every single function of the instance function, you need to put a self there. And here we call it this. If you don't like this, you call it self. That would also work. Let's use a self, okay? Because make it sound like a instant function. Okay, it's still open now. So by doing this, let's take out this one. Okay, I'm writing it more like an object-oriented program, but it's not an object-oriented program. I'm writing like this. So let's have the double function. I'm going to actually this one. I'm going to do that x. So here I'm going to put a integer body of self, and I'm going to return self.x, self pointing to x. Okay, let's actually make this. Then change this one to y. It's called get y function. Okay. And then let's put another, this one, let's call it following function. Here, let's call it set x. Here, let's have a double x. So this one still pointing to x equals x. one, one, one. So far, okay. And now I'm going to include mesh.h because I'm going to calculate the double norm. So get x, get y, set x, x, y norm. Okay, I print point x, and here I'm going to do double n equals p1. P1 is a point, P1 the norm. No, I'm sorry, I made a mistake. Whenever you use a pointer, you must use the edges, okay? And then here in the F. So far, okay?
Yeah.
How about Jessica? Are you okay so far?
Yeah.
Okay. So this one is C version, okay? Let me send this 3 file to you, you compare, okay? 3 file means I send you the Java design and also C Python design and also, so this Java point. Python point. And C the point. So far, I'm only working on C the point. I haven't worked on the .h file yet, okay? Because so far I'm using this self-tested portion to make my structure point working. And this structure point will be used by the same class so far. Now, this is not enough because sometimes you might have a test point or some other function, some other module they may use it. Okay, they may use this structure point. So you want to make this module reusable by other class, right? By other module. That's why we need this pre-processing part. Okay. Now we are going to give you the example before we come to the slices. Okay. So because we want to do that, so here we are going to write a .h file. So before we write a .h file, first thing that I will do is right here, I'm going to define main. Okay, if you have a define main right here, you will say, you will actually do if define main. If you define main, you will compile this part, okay? And then right here, you will do end if. So this one is to tell the compiler, a preprocessor, my main already been defined. So because my main already defined, then I'm going to turn on this whole thing to compile. So when you compile, you will get the main function and run. Okay, but sometimes you want to use this as a module, so you don't want the main part to work. because you just want to give other people the different data structure for other module to use. In that case, you disable this one. You don't define main. You don't define main, then this main function you see here is actually being turned off. So it is no longer useful. Okay, it's no longer useful. Now let's get started from here. You turn off the main part, so you got this one, and you want this one to be shared by other module. So right here, you go to your .h file, and you do if not defined. So if nobody included before, then you will define your point underline h. This means if not defined, if the point h not defined, we will define it. And then here you will have and if. Okay, so anything writing down here means that if the .h file already been included, it will not be compiled again. If it already been included, it will not be compiled again. If it has not been compiled yet, then it will be redefined again. Okay, so you are going to put these different things into the .h part. Okay, and then this is fine. This is fine. This one you do not need the implementation. This portion 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 you do not need the implementation. You just need the so-called prototype part, header part. So you put this everything that you want to share right here. Go back to this function. So right here you got this one. So you can do include point.h. Because you include point.h, so this two is no longer needed. But the implementation function needed because your .h doesn't have the implementation. Any questions so far?
No.
No? How about Jessica? Are you okay so far?
Yeah.
Now we want to use an external program, so let's actually create another one called test point. Let's see, okay. Let's create a program called test point. Let's see. Let me put it into lowercase, okay. The name is no good. Let's call it test point. So in this test point, let's see, let's actually copy this one and put it right here, okay. Put it right here. And here I'm going to do include stdio.h include point.h, okay, and then it is in. So right here I'm going to do one more thing. Let's do print. Okay. In test point module. So this one to tell people that I'm not using the test point program in the point.c. I'm actually in the test point.c. So I include this. So this one work. Let's save. Now when you compile, be careful. Okay, when you compile, be careful. Let's go to the terminal. When you compile, you have to do G++ point.c test point.c. You need to include both of these .c file and then .ho test point. And now why test point? Oh, I'm missing the but point.c test point.c ho test point. Then wrong test point. Is that okay so far?
Yeah.
This one seems I forget to do change line. Let me change it, okay? Go back to this .c file, this right here. I think this one should put the specification. That's it, okay? Because right here, there is no change line. I don't like it. Okay, let's go again. Okay. So Jessica, is that okay so far?
Yeah.
Knowing how to write a module in here. Okay, making sure you understand it, okay? I use
So
the
you don't so you don't need the math.h on the test point one?
math.h, no, because math function is this one is included in the .h file. .h file already know it.
Oh, okay.
This one is included in the point.h file, point.c file. Point.c file already find your math.h. So in your test point, no, you don't need that because you never call the SQRT in the test point. Right here, you do not, do you see any SQRT? No, you don't see it. Here you do see it because you call it caller here, so you do need the math.h here, yes. In your point.c, yes. But in your test point.c, no. It's okay?
Yeah.
Yeah.
Because here you call it in the point.c, you call this a square root function. But in your test point.c, you never call that function. You just include the point.h, and whatever point.h has, it will solve the problem by itself. Okay? So this is the way C language write the structure programs structure. Okay? You can use no point as well, but if you use no point as well, when you call the object here, you will have no edges, but you can only copy the value to the structure. Then you cannot update the structure. Okay, so then your set x, set y will not work if you don't have the pointer. It will just update the local variable. Is that okay? Does that make sense?
Yeah.
Okay, let me give you this point C, point.h, and the test point again. Okay, you can take a look. Okay. Making sure you really understand it. This is one module. So every time you have a class, it is developed like this. Okay. Now next one, because you're going to compile this and it will take time. So usually we will write another program that's called it go test .bat file. BAT is called batch file. Is it a Windows script file? It's called .bat file. The .bat file is batch file. Okay, BATH. Batch file is a program that would run the commands. So here you put G double prime, but std equals C17. This one is says standard using C language 2017 version. Okay, that's this. You can also use minus WO. This one is turn on all warnings. All warnings. So if there is something wrong, turn on every warning you may have. Okay. And then you compile your point, the C plus point, the C output the test point. You run this one right away, so you do test point right here. And you do save and come here now, you do go test. Okay. Oh, this one is not G, it's GCC. Okay, I'm sorry. This is C compiler. I made a mistake. Okay, I'm sorry. It's to go test one more time. No such, cannot find such a file. This point C, wait, cannot find. Let me do PIR. OBAP, we had a point that ESE. This one, let me take out this, okay? I'm not, this one equal, this one, because here I type it should be minus, it's not double equal sign. Make a mistake, okay? So do test one more time. Okay, so compile and run, okay? Sorry. This one, the batch file, I cannot copy. I cannot actually. I cannot send it because batch file. Facebook won't allow it. So let me copy it to it. Okay. That's the batch file. Now we actually finish one class design. Okay, let's go back to our slides. So we learned a few pre-processing. Now we are going to look at the what is pre-processing, okay? So pre-processing is the language that you tell compiler what you would do. Before you compile your language, you will do pre-processing. So usually this sharp sign include that is pre-processing. Sharp signs defined as pre-processing. Sharp sign if undefined as pre-processing. Sharp sign if defined is pre-processing. Sharp sign and if it's pre-processing. This actually control your language so that you determine which part you will compile, which part you will not compile. Okay, that's called pre-processing. Java don't have a pre-processing, and Python don't have pre-processing. This one is usually only in C language and C++ language. It pre-process your language source file, and then you compile it, okay, and then you assemble it, and then you link it, okay. So C preprocessor, also sometimes called CPP, is a microprocessor that convert your language from the .c file to a real file to be compiled. So it is before your compiler, CC compiler or GCC compiler, okay? So you have a .ccp file, you preprocess it, it changes to another .cpp file if it is C++, and then you do compilation, okay? And you can assign character set. Sometimes your program may have Chinese, then you would like to set to allow some of the Unicode to work in the main source code, okay? And then you can turn on overloading, turn on the version of your compiler. So C language, we use GCC, C++ language, we use G++. Okay, this ALL is turn on overloading. This STD is the standard of your compiler. You can assign it as a C17, C11. They'll pick different language. So right here, G++ is C double plus. So C double 11 version is like this, okay? Okay, this one you can also dump to assembly. Okay, let me show you this dump to assembly part, okay? So sometimes your GCC, you may want to dump to assembly instead of writing to a executable code, okay? So let's do this. So let's do GCC, this one, let's see, this point, let's see, this, EIR. Then there's a point.s file, there's a point test point.s file, right? Let's look at point.s file. This one is assembly code. Okay, so this is assembly code. Okay, is that okay?
Yeah.
It's using what? Let's go back. It's using dash capital S, big S, okay, not small s, big S minus big S. You would dump to assembly code. So this one will be useful when you take the ICS 51, the course in Irvine. When you do C language and assembly, you will need that. You will need that dumping function. Jessica, is that okay?
Yeah.
I'm trying my best to link to your class, okay? In ASU, so this one will be going to this ICS 51, okay? You will need to dump it to assembly. ASU also have a course, ASU Computer Organization and Assembly, ASU 230, okay? ASU 230.
Okay.
Okay, so be careful. That also be important. So that's why here I try my best to include everything. Include everything means that you may need that later, okay? Just to show you what happens in the pre-processing stage. How can you get your assembly code, okay? And you got this assembly code. And then next one is macro. Macro is for macro function. Last time we defined the macro function already, okay? So macro, you can define a pi value. So whenever you see capital pi, it will be replaced by a number. So this one is similar to be constant, okay? So in C language, we have two ways to write constant. One way is to define pi. The other way is to do constant double pi. Okay, let's write it in program. So here I'm going to create a new program. I'm not going to compile it, okay? So here I'm going to do constant. Let's see. I'm not going to compile it, okay? So you have one way you can define pi as 3.1415926 as a pi. Another way to define it is into constant, okay, double pi value. Okay, I avoid using the same name, okay? Both way can define a constant in C language. Is okay?
Yeah.
Let's give you the example. Wait, I get to the wrong part. Okay. Let me close this one. This one actually is wrong. Going back to here, okay, that's actually the constant part. You can also define the macro function, and last week we talked about it already, so I don't repeat that one, okay? And we do not encourage you to write that anymore because that causes a lot of trouble. It is doable, but not something we would recommend. So macro function, constant value, verbose. Verbose is if you want to define something. So sometimes you have a pair, and then if you right here have a defined verbose, then this portion will be compiled. If no, this portion will not be compiled. Okay. So this what does this mean? This means that you can define verbose. So when you do verbose, this will be used. Else, this will be used. So this means that verbose means a more tighter way to say something. This one means that a simpler way to say something. Let's try it in the program. Okay. This is conditional compilation. So let's create a new file. Let's call it conditional compile. Let's see. Okay, conditional compile. Let's see. So here let's do include. Yeah. Okay, I define verbose. This variable called verbose. Okay. So what that is a verbose would do? Let's actually have a main program. Okay, it is a function called message. So right here, let's have the void message. And this one should be a doctor, okay. And then it's a string, so let's call it message. The message. So here you will do what you do. You will do so if verbose being defined, so here you have verbose being defined, then you do printf, okay. Okay. Two different versions, right? So far we define it as a verbose version, and we run it. You'll be welcome to see them with Mr. Tom Cruise. So now here, if I disable it, then the verbose version being disabled, then I'll compile this version, a simple version. So we say, hi, Mr. Tom Cruise. Is that okay?
Yeah.
Jessica, is that okay?
Yeah.
So this one give you one program that you can compile to print this or print this. depending on you turn on the verbose or not. So this one define verbose with turn on verbose. Okay, conditional compilation. Java don't have this, okay, and this is that useful? Maybe in the old days people like this, but nowadays I don't think people use AI will still do this kind of proposing. No, the proposings, okay, is actually wasting life. Macro definition with keeping. So pre-processing, it will help you to arrange the data and then make it compile in different way later, okay? Some of the more advanced programming like CUDA in NVIDIA, some for loop, you can use a parallel to run it. So this kind of pragma is very important, okay, to compile the whole thing in parallel. Okay, this kind of pragma is very important later when you use parallel processing. So you can search C language pragma for parallel processing. They do have that, okay, and you need to use pragma OMP parallel, open multiprocessing. Okay, this is beyond our touch, but that's making this whole thing parallel, and you can include the OMP.h. Okay, so this when you need to do parallel processing, put in your C code to GPU. Okay, right here you just know that pragma someday you may need it. Okay, that's all you need to know. Is that okay?
Yeah.
And as for how to use it later when you do parallel processing course, they will teach you to use a pragma right here to make the for loop can be done by parallel, using parallel processing, using GPU, okay? But not right now, it's a little bit too much right now, okay? Just give you the introduction. Let's move on, okay? Move on. Okay, so include will include the header file from other module. So usually they'll tell you what variable is shared variable, what function is shared function, public function, so you can use. Okay, so usually you have using the bracket, okay, angle bracket. This one is to include a standard library. Double quote is to include local files, okay? And the include file, usually you have the, if not defined, the capital of the file name underline H. We use this because this, you will not have the duplication. So this one and the enter if you one pair, and this one is defined inside the if not defined, okay? Is that okay?
Yeah.
But Jessica, are you okay?
Yeah.
This is every time when you start to write a new program, whenever you write a new file, you must write this and this first before you put into the something in the middle, okay? Later, you can develop your own bank account class, array, a dynamic array class, okay, using structure by yourself, okay, later. We will have homework to do that, okay? You need to do that, trying to compile multiple files together, okay? So that's the inclusion. In C language, C double plus language all has it, okay? So here you have the typical C header file usually that you would typically use. Complex numbers, std.io, wider characters, limits, maximum, minimum program, string.h, time.h, floating point.h, mass.h. These are the standard integer.h, standard library.h. These are the more commonly used standard libraries. Okay? Any questions so far?
No.
No? Let's do one thing. Okay, let's do one thing. Let's finish it out. Okay, like here, let's actually do one thing. Let's create a new program. Let's call it STC double plus program. Okay. I'm sorry. Let me change the name. Let me change. That's not a good name. Let's do data.c. Okay, let's do data.c. That's the question that we have a program of data.c. We include stdio.h and then integer main. Okay, and then boy. Okay, and then here we do zero. Okay, here we do have include. Next.h. Okay, let's do this. Okay, and then have a integer x equals -3, and then integer y equals abs of x. I do use the math library, and I convert the absolute value. Okay, so here I do print up the absolute value of percentage e is and then this x and y here should be. So far, okay.
Yeah.
Change guys, okay.
Yeah.
This one is to save. Okay, and then let's run it. You get a result. Okay. Now this is data to C. Let me create another file. Let's call it data.cpp. It's a C double plus language. Okay, so let me copy this data.c over to CPP. Okay, right here, let me change it. Let me change this one to C standard.io C mass. Nothing else will be changed. Everything the same. This file name now is the CPP C double plus program, and let's just run it. You get the same result. Okay. So what do I tell you? What I told you is that I have a .c program to a .cpp program. This one is to include stdio.h, then include mass.h. So I write a C program, and I want to convert it to C double plus program. This C stdio, the stdio.h, I put a C in front of it. Mass, I put a C in front of it and put it over here. Boom, that's it. The C language can be all included in C double plus. So that tell you that C language actually is a subset of C double plus. Is okay?
Yeah.
That just tell you the relationship of C language and C double. I should say this is not exactly correct. Maybe just like this. Maybe it's like this. Maybe C language like this. A little bit of C, some portion of C, C++ cannot do it. It's basically not related to assembly or register. But I don't think a lot of people would use this part. So normally, conceptually, we are saying that C is a subset of C++. That's why we teach you C language first before we go to C++. Does that make sense?
Yeah.
Okay, Jessica, is that okay?
Yeah.
So don't worry that we are not teaching you C++ yet, but in fact, we are teaching you the basic C++ already because it's called C. The core part is called C. Okay, the mathematical function is always in there. So as long as you know that this one, okay, this one will be CSTDIO in C++. Okay. This one, STD library, you put a C in front of it, is like this. String will be C string. Okay. Time will be C time. Okay. And then math will be C math in C++ language. You can directly convert a library into C++. Okay. STD integer is a C STD int. Okay. Float will be C float. That's it. This is the very easiest way to convert C language to C++. Okay. And here to tell you what is the important file. Okay. These are the library you will include. Okay. They give you what kind of function, whatever, Dewey string. These are the function. These are something we'll teach you later. Okay. Memory allocate, the printf, okay, whatever. But before you learn these different files, you must remember every function you know learn later can all be used in C++. Just put the name of the module there and then put a C in front of it. That's it. That you can put it into C++. Okay?
Yeah.
That's what I try to teach you. Conditional compilation, I talked about it already. Okay? This one, okay. Multiple file, I teach you already. So chapter 7, we are done. Okay? Work on the homework. Okay? Any questions so far for this chapter 7?
No.
Chapter 7 teach you how to compile. Chapter 7 teach you how the pre-processing of the data is. Chapter 7 teach you what is a constants. Chapter 7 also teach you what is a module. Chapter 7 also teach you how to convert C language to C++ language. Okay, that's what chapter 7 is. I'll go to the chapter 8. Our goal is to finish C language before the end of the July. Okay, starting from August, we'll move into C++. Okay. So at the time you go to your college, the basic C++, the end of the September, we will be very sure that you will be finished. Let me see now here. You will finish your basic C++ already. Don't worry, okay? And then for Jessica, you may need a C45 in the third, fourth quarter, so it should be fine. Okay, you can continue with us if you have time. If you don't, it's also okay. Up to you, okay? So chapter A is pointer and array, okay? We do cover this pointer and array before, but here we are going to introduce another times, making sure you understand it, okay? And because last time we covered it, we do not have the idea of the module, but right now we are going to teach you with the idea of the module, okay? So let's get started with the C pointer and array. So pointer and the edges. First one, you have a variable integer A equals 3, you store 3 at the memory location of A2B4 with 3. So ages of A, this value would be A2B4. If you have an integer star P, the body of the P is an integer, so P is a pointer. So let's assume that you actually do assign this with ages of A, then P will be storing A2P4. Then the variable that you're pointing to, that we call it body of P, should be 3. Any questions so far?
No.
How about Jessica? Are you okay so far?
Yeah.
Must remember, okay, this one a little bit more confusing. Java don't have this, okay? Let's use a program for it. Let me create a different folder. This is chapter 8, so let's open a new folder, okay? It's now in chapter 7, let's create chapter 8, okay? Array of pointers. So first let's create something called pointer P pointer. Okay, P pointer. So we have available A. We would like to know about A's value and A's ages. So this one you create integer A equals 3, means in the memory, some memory location here, you put a value of 3. So this A that you print, you get a value. When you print it, you get a value. And the ages will be printed right here. You use the ages of A, you get the ages of A. Let's print it. Okay. And this one, you got the negative value because it is a signed value. So here you want it to be unsigned. So let's use U instead as an unsigned integer. Go one more time. Then it's a positive value. Okay. Does that make sense?
Yeah.
Sometimes you may want it to have a certain digit. So let's do leading 0 for 16 digit. Okay. Leading 0 with 16 digit. Okay. It will be an address like that. Any questions so far?
No.
No.
Or you may want it to be hexadecimal value. Okay. The hexadecimal value. Let me list down everything. Okay, so this is ages. You can have many different way to bring it. So you can be can be U 0 16 U 0 16 X they'll give you different value. Okay, this U is unsigned integer, but it's a decimal value. X will be hexadecimal. Any question?
No.
How about Jessica? Any question?
No.
Okay, this one actually is ages. Now let's look at the pointer. Okay, so let's do P pointer 2. Let's see. So here I have the integer a equals 3. Okay, let's print a equal percentage e. Okay, slash n. Okay, a. Okay, and then let's do change 1 of a, and then let's print it. Okay. So here we do have a function called void change one integer a integer x, and then a equals x. So here let's put in 4. So what happened is this one you pass the value to the 3 to the function. Okay, to the function. But this function you actually when you pass it, your main function has an a of 3. Your change 1 has an a, and you copy the value of the 3 to here. And this variable is changed by the value of the x, so it changed to 4. But your a in the main function still be 3. So here you print out a is still the same. This is passed by value, so your a unchanged. Okay, so this is not what we want. So if you want to update your variable here, you need to use void change 2 integer x integer a integer x. But this integer a, you would like to use a pointer. So let's call it a pointer. Okay, so the data that a pointer pointing to, the body of this will be updated by x. Okay, so this one you do copy, you do change 2, you do pages of a. Okay, what will happen is the change 2. Let's look at it. Okay, so you have a main program. You have a main program. You have a in there. You store 3, right? And then you do change 2. So change 2, you do have an AP variable. This one is right here. So AP variables, the body is an integer, is a pointer. This pointer will store the ages of a, that's essentially storing a2, b4. So it's a pointer pointing to here, right? This AP is a pointer. So AP's body is the way the location it's pointing to, changed by x. X value is 4. So you update this a. So here is a become 4. So what this one is making this one as an in-out variable. This one is only input only. This one is in-out variable, both input and output. You can update it, you can input it, you can also update it. Okay. But when you do use the body, you need to use a star to talk about the location that you're pointing to, because they're indirectly pointing to there. Is okay?
Yeah.
How about Jessica, are you okay?
Yeah.
So that's when you want to update a variable, you will need that ages. That's why when you do scan F, you have percentage D. Your scan F always is ages some variable A. Here you always need that because you are going to update the value, okay? That's a pointer, that's very important. You got the A04 here, okay? You got updating. So that's the difference between the ages and body, okay? Now let's look at the array. Well, remember that the C language do not have the arrays length, so you need to do a length like that, okay? And then you do integer a array of 3 equals 10, 20, 30. So this is just like eta length, okay? It's just like eta length, and you have this one. Okay, so this one you should be able to print out every value in A. I make a mistake. Should be less than, okay. Okay, so you print out 10, 20, 30. Now, let's assume that we have the integer body of P would be equal to ages of A equals A. So A store the ages of A0 element. Is okay? So when you declare A array 3 equals 10, 20, 30, it actually create A that pointing to a array of index 0, 1, 2 with 10, 20, 30. And this A is storing the ages of its starting ages of A0. Is okay so far?
Yeah.
Are you okay so
Yeah.
far? So integer body of P, this means that body, this is star called body, this is called ages. So body of P is an integer. So P's body, the location that P pointing to is an integer. That's what this one means, okay? The body of P. So body of P is an integer. So P assigned with A is the A's ages being assigned to P. Okay, being assigned to P. P is a pointer to ages. Now we got that one, and then we do. Okay, let's print out, not print out that, but print out body of P. We print out the body of P. Okay, we print out body of P. So P originally pointed to A, we print out body of P. Then P increased. And then we print out body of P again. And then P increased. And we print out body of P again. That's it. Save and run. 10, 20, 30 also be printed out. So what does this mean? This means that your A store with index 0, 1, 2, 10, 20, 30. So P as a pointer, P store the value on the beginning part of this one. So you actually print out body of P is here, and then body of P increased. The P increases, P pointer increases, so P pointing to the next one. Then you print out the body of P, you print out this one. And then P's value increased. You print out the value of this one. This is how you use the pointer. So this one is a calculation of the ages. P++, if your ages advanced by 1, you move on to the next ages. Is that okay?
Yeah.
Yeah.
Okay. Now this one actually every time you move on by 4 bytes, because this body is a pointer to the integer. Now let's try something else. Let's try factor B array 3. This one do 3 capital ABC in B array. Okay, so that's like that. So capital body of Q will be equals B. So B is a pointer to the capital array, right? And then we are going to print this one. This one, let's do body of Q is a capital type. Body of Q, capital type. Q increase this one, Q increased by 1 byte. Interesting. This one is the P increased by 4 byte integer address. Is that okay? That increment actually increased by the size of the integer or character. Integer is 4 byte, character is 1 byte. And then let's do it several times. Okay, the last one don't increase, making no sense. Save, run again, and they print out ABC. Okay. This shouldn't tell you that the increment actually increased by the pointer size, the data type that you increase. Any question?
No.
How about Jessica? Are you okay so far?
Yeah.
Okay, so that part is the pointer to variable. Next one, we are going to talk about second level pointer, third level pointer, okay? So we're PP.2, let's go to PP.3. We're going to talk about level 2 pointer. Level 2 pointer, integer A equals 3, integer pointer P equals ages of A, integer body of Q equals ages of P. So this is 3 create such a a relationship A store with 3 is A2 P4. P store with the address of A. It is pointed to here. Then this address maybe is B2 F4. Then your Q will store with B2 F4 and pointed to here. So Q pointed to P, P pointed to A, okay? So that's print. Okay, we have A variable, we print out the address of A. And then we print out P variable. And then we print out body of P. Okay. Then we print out address of P. Then we print out the body of Q. Finally, let's print out bodies of Q. No, this one doesn't work. Anyway, let's comment it out. Okay, up to here so far. Okay. So this one has to C, okay? So this one A store with 3. The address is A5 BFF9A4. Your P store with A5 BFF9A4. It is pointing to this variable here, okay? Then you do have a Q value is storing A5FF97A. Okay, and it's pointing to here. Okay, it's pointing to the address here. So this address is A5FF978. Okay. So let's see here. Okay, so quite complicated. So A value, you print A's value, you got this value 3, no problem. Address of A, you're printing this one, that's no problem. Then you print the PP's value is this one, no problem. P's body is the one that you're pointing to, is HLS3, no problem. Address of P, you are storing this value, no problem. Okay, so this one should not be body of Q, it should be Q's value. I'm sorry, this one should be Q's value. Say one more time, okay? Let's go it one more time. Okay, so this address will be put into here. It's actually the same, okay? It's the same. So it's pointing to this body here. And you do double value, double star means that the body of Q's body, it jumped back by two times. Body of Q is the Q's pointer values body's body that you print out is 3. Is that okay?
Yeah.
How about it?
Yeah.
Is that okay? It's a little bit complicated, but it just teach you label 1 pointer P, label 2 pointer Q. Okay, so this one is integer. This one is label 1 pointer to integer. This one is label 2 pointer to integer. So next week, we are going to continue to talk about label 2 pointer, label 1 pointer, and array, and 2-dimensional array. Okay? We are up to here today. Any questions so far?
No.
Okay, so these are very important so far. Okay, it will lead you to know about pointer later. Right now, this week must understand what is point 1 pointer, point 2 pointer, level 1 pointer, level 2 pointer, and it's body of the level 1 pointer and body of level 3 pointer, and also body of the level 2 pointer. Okay, this one, the double dereference. Okay. Okay, up to here, and try to finish the homework up to chapter 7. Okay. And next week we are going to finish this array part and pointer. Okay.
Yeah.
Okay. See you next time then. Bye bye.
Bye, Mr. Cho.
Bye
Have a
bye.
great night.
Bye bye.